Okay, so these are straightforward definitions. A ratio is the relation between two values. It shows how many times one value is greater than the other. Okay, a proportion is simply two equal ratios. Similar polygons are two figures that have their corresponding sides in proportion, and they have their corresponding angles equal to each other. So all of that must be true for them to be similar by definition. The extremes of a proportion, if we have a simple A over B equals C over D and we cross multiply, this is referred to as the extremes. Okay? So I'll pause it, but make sure you have this down. Straightforward. Okay, I'll talk more about this, but for now let's put definition. We have angle, angle, side, angle, side, and then we have side, side, side. And I'm going to make a little note. Think proportions. Once we know they are similar. I'm going to get rid of the R. Okay? These are shortcuts. Okay? So think proportions once we know they're similar. Okay, let's go down. Okay. For this one, what I would do is, let's do the second one first. CEG. I'm just going to look at the top. CEG. So it has to be the last three. X, Y, W. I didn't even look at the picture. Okay, so we can do that. Here we have to set up a proportion for A. So 16 over 2, right? Because this side corresponds with this side. 16 over 2 equals AC over 8, and this should be a 2. So 8 times 2 is 16, 2 times 2 is 4, so AC equals 4. Okay, so AC is 4. Okay, so we have to say what makes these similar, okay? So look at this. All angles, corresponding angles are equal. All sides in proportion. I'm referring to number 7, by the way. So they're similar by definition. Okay? 7 is similar by definition because all 6 of them are true. All the angles are equal. All of the sides are in proportion. So a lot of stuff is true. If you look at 6 carefully, this side has to be 60 degrees. So look, we have an angle, angle. So similar by angle, angle. Here they're not similar. The angles are close, but this is 40 and this is 39, so they cannot be true. Okay? Not similar. AA doesn't work, so we're going to say not similar. Okay, this is going to be, this angle is the same as this and this. So we have angle, angle going on ABE is congruent to ACD. Pretty straightforward, okay? All right. Let's do these slow. These are the toughest part of the test, I think. And then let's go through it slowly. Let's make it bigger. Okay. let's take our time here. All right, let's separate it. Okay, so let's do this one. I'm going to take the time to separate it. So we have, and then we have, so we have, obviously they're the same top angle. We have a right angle given, 4, 5, and this is 8 plus 4 is 12, 5 plus x, right? So let's focus on, these two triangles, similar by AA. The moment we know that, we can set up a proportion. So 5 plus x over 5 equals 12 over 4. Okay? So we got it to here, and we just got to finish up the work. Okay? We did the hard part, in my opinion. Okay? So the moment you know they're similar, you want to really think about what proportion can I set up. Okay? So we separated them, we figured out angle, angle, and we're in good shape. All right, 11. Let's again separate them. So I have my small one and my big one. This is 4, 6, and this angle is equal to this angle because of parallel lines. So this is 4, this is 6, this is 16, 6 plus x, and then we have angle, angle. Right? So they're similar by angle, angle. The moment we know that's true, think proportion. 6 plus x over 6 equals 16 over 4. Right? The rest is just algebra. So make sure you have this, and we'll go ahead and solve that tomorrow. Okay? All right, 12. Again, let's separate them. So this angle is going to be equal to this angle. So once you separate it, you really see the patterns much, much better. Let's get rid of this. Sorry. All right, so again, let's separate them. This angle, this angle. Okay, so, I mean, pretty soon, guys, you get tired of separating it. You just want to, not do it over and over again. So if you see the pattern, you don't have to do it, obviously. This is 4. This is 5. This is 6. This is 8. This is y, 5 plus x. Hard to see, but they're similar by angle, angle. Think proportions. 5 plus x over 5 equals y over 6 equals 8 over 4, right? And we're going to work on that, but this is your setup, and in my opinion, the most important step. Okay? Notice how the triangle is right. I separated them, okay? Let's go to 13. Okay, so what makes these similar? Side, angle, side, right? 3 times, so 6 over 3 equals 4 over 2, and then they have this shared angle. So we automatically know it's side, side, side. But the moment we know they're similar, we can think proportions, right? So let's make a proportion. 6 over 3 equals x over 4, right? 6 over 3 equals x over 4. 3 times 2 is 6. 4 times 2 is 8. So x has to be equal to 8, okay? So really focus on the reason. What makes them similar? Side, angle, side. All right, 14 is hard to see at first, but what I'm going to do is I'm going to erase the top triangle and separate them so it's much easier to see. 5, 4, 6. These angles are equal because of vertical angles. So look at that. Let's forget about this triangle and focus on this one and this one. What makes them the same? Side angle side. The moment they're the same, think proportion. 10 over 5 equals x over 6. 5 times 2 is 10. 6 times 2 is 12. Right? Similar by SAS. I'm going to say similar by SAS. Okay, so the justification is really important. So again, separating them just really makes everything so much easier in my opinion. All right. Here, look, their sides are in proportion. What I mean by that is 6 over 3 equals 8 over 4 equals 10 over 5, and they're all equal to 2, so they're similar by SSS, side, 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 similarity theorem. Okay? So that's all you have to say. Okay, so we got some problems right here. You just have to remember what to do. This one is, it makes the little t, so x squared equals, you want to multiply the legs, so we get 36. What times what is 36? We get 6. Okay, not a big deal. This one is slightly different, so here's the way I like to recommend it. So it's this side, one of the sides of the legs. This is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. So what the heck does that mean? That means we start off with our x squared. Then you take the whole bottom side, so it's 12. And then what's the one closest to the leg? It's going to be 4. So x squared equals 48. X equals root 48. Okay. And then we could simplify that in class together, but for now we'll just put root 48. Okay. I mean, officially it should be root 16 times 3. This is a perfect square, so we get 4 root 3. Okay, if you want to simplify the radical. All right, we got 18 left. So this one is, again, always start with the side squared. X squared equals whole 6 closest to the leg, so it's 6 times 4. X squared is 24. So x equals root 24. Rewrite it as a product of a perfect square and some other number. So we get 2 root 6. Okay? It's 18. 19. Do 19. Whoa. So we got one more left. Okay, so good problem. The perimeter is, I'm just going to draw a picture. Since we don't know what it is, I'm going to call this 5x, 8x, and then 10x. So perimeter means we walk all the way around. So 5x plus 8x plus 10x equals 46. So we get 23x equals 46. X equals 2. We're done, right? Nope, we're not, because it wants the longest side. Longest side is 10x. So 10x equals 10 times 2. So it's 20. Okay? So the problem is really made easy once you attach an x next to the ratios. Okay?